All right, a little bit of unit circle review for you guys. So first, just some general things about the unit circle. This is our 0 or our starting point here, and in general, we move around the circle this way if we're given a positive angle, but this way if it's negative. And we've already determined that the sine of any angle that they give us is actually just the y coordinate on the unit circle. The cosine of any angle they give us is the x coordinate on the unit circle, and the tangent of any angle is the y divided by the x. Okay. So let's talk about a couple different strategies of how to approach when you're looking for something that's a negative angle. So when they give me a negative angle, I basically want to move this way, but it's difficult. Oh my God. So first thing, if it's a negative angle that that's on here in a positive, you just want to be able to compare it the other way. So let's say I was looking for an angle of negative 150 degrees. So to understand that location, my advice would be to look at what positive 150 degrees is. So that's right here. Notice specifically it goes from 0 almost to 180, and that it's 30 degrees away from being 180. So I can kind of see that same thing in the other direction. If I started at 0 and tried to emulate that with a negative, that I would go almost to 180 and leave that 30 degrees away. And then I would know that this position right here, which is marked on my circle as 210 because we've only named positive angles on it, is the same position or is coterminal with that negative 150 degree position. Okay. Let's say they gave us negative 7 pi over 4. Okay. So I'm going to erase what I had on here and kind of do the same thing just with that one. So if we erase, sorry that you can hear my kids in the background. So if we erase and then go through that same procedure, there is a 7 pi over 4 right here. So 7 pi over 4 means this, though, that it went all the way to 180. It went through the next quadrant and then into this fourth quadrant, 7 pi over 4. 7 pi over 4 is a 45 degree. It's the last one before you finish the whole circle. So that's kind of what I would take note of, like the last position before I finish the whole circle. And so if I went this way, I would do all the quadrants, and then I'd stop at that 45 degree position in that last quadrant before I finish the circle. So this position is coterminal with or lands in the same place as 7 pi over 4, which is that pi over 4. Okay. All right. And then some advice on how to get some of the larger angles that aren't listed on the circle as well. So let's say, I guess we'll start with pi over 4s again. Let's say they give us 17 pi over 4, and then we were trying to figure that out. So here's 0. So one way is to count. So to count, you have to recognize what 1 pi over 4 is. So here's a pi over 4. You need to recognize that those are every 45 degrees. And so here would be all the pi over 4s highlighted on the graph. And I could literally just like keep going and count them in the positive direction. So this is like one method, is like counting. All right, that was Lucas saying night night. So that's your guys' special treat. I'm sure that's more interesting than what we're doing here. But so first thing is by counting is how we could go. So see how I've marked every pi over 4. So I would start at 0. Okay. And then I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 pi over 4. So this position at pi over 4 is coterminal with or lands in the same spot as 17 pi over 4. So that's one way, just counting. The other way, or another way, is by subtracting 2 pi or 360. So when you look at 17 pi over 4 and you know that it's not on the unit circle because it's already more than one whole lap, then I do 17 pi over 4 minus 2 pi. If it was degrees, I would subtract 360. So this is really like having 8 pi over 4. 17 pi over 4 minus 8 pi over 4 leaves me with 9 pi over 4. Now notice 9 pi over 4 is still not on there. That means I've gone one whole lap around the circle and didn't reach 17 pi over 4. And I can still see that I am capable of going a whole nother lap around the circle, and there still isn't that number. So I'm going to subtract 2 pi again, another whole lap around the circle, which again is like 8 pi over 4. 9 pi over 4 minus 8 pi over 4 is pi over 4. That's on my circle. So see how I subtracted 2 pi twice? That means 17 pi over 4 is 2 full laps around the circle and then this extra pi over 4. So that means it lands right back here at pi over 4. So that's way number 2 of getting that, is by subtracting 2 pi. And then another way, and this just depends on your comfort with like writing numbers in different ways that might help you get there a little bit faster, is using like pi and 2 pi as reference. And when I say that, what I mean is I look at 17 pi over 4, I see this 4 right there stands out to me, and I kind of want to think about everything in the world of fourths. So I have 0. If I go over here, it says pi, but what is pi in fourths? It would be 4 pi over 4. And then I get back around the whole circle, it says 2 pi, but what would 2 pi be in fourths? It would be 8 pi over 4. That means every time I go a whole lap around the circle, I get 8 pi over 4. So it's kind of like counting, but it's counting by like bigger chunks than every single pi over 4. So I see 17 pi over 4 is where I want to land. I do one whole lap is 8 pi over 4. Can I do another one? Yes, because 8 plus 8 will be 16. So I do another one. That's 16 pi over 4. I need to go one more pi over 4, which will land me right there at that space of pi over 4. So just a couple different methods in case you forgot. And then I'm going to go through 2 ideas here. So the first one says sine of 19 pi over 4. So you could either count 19 times a distance of pi over 4. You could take 19 pi over 4 and subtract 2 pi's, or you could use some reference angles. I'm going to use these references again because I can get there a little faster. So again, I start at 0. One whole time around the circle is 2 pi, but I'm going to think about it as 8 pi over 4. Can I go another 8 pi over 4? Yes, because 8 plus 8 is 16. That still isn't 19 yet. Can I go another 8 pi over 4? No, because 16 plus 8 would be 24. Okay, so I've gone 16 pi over 4 and landed at this same spot, and I need to go 19 pi over 4. I am able to count in my head the distance between 16 pi over 4 and 19 pi over 4. 16, 17, 18, 19 means it's 3 spaces away from pi over 4. So if I count 1, 2, 3, 45 degrees, that puts me right here at the same position as 3 pi over 4. So all that's done is show me where this would land. And now I want to calculate the sine at that position, which is the y coordinate, which is rad 2 over 2. So this will be rad 2 over 2. For negative 7 pi over 6 in my part B here, since that's a negative angle, but I see its positive counterpart on the circle, I'm going to use the strategy we talked about before. So here's 7 pi over 6, which means going 7 pi over 6 is going 180 degrees and then going an extra 30 degrees after it. So if I do that in the negative direction, I would go 180 degrees and then an extra 30 degrees after that, and I would land right here. So negative 7 pi over 6 lands at the same position as 5 pi over 6. I'm supposed to find the cosine of that angle, which is the x coordinate, so negative rad 3 over 2 in that case. The last angle I'm going to look at looks large and has a negative, so I'm looking at part C here. So it has tangent of negative 23 pi over 6. So I see that sixth. I'm going to try to think of everything as a world of sixes. So this is 0. This is pi, but I'm going to think of it as 6 pi over 6. And then getting back here is 2 pi, but I would think of it as 12 pi over 6. So Before I go negative 23 pi over 6, let's just think about it positive for a minute. So 23 pi over 6. To go one time around the circle is to go 12 pi over 6. If I tried to go another time around the circle, that would be 24 pi over 6 because I just added two 12s together. 23 is so close to that, but right before it. So what it's saying is that I go all the way around the circle, and then I almost do a whole nother circle, but I stop 1 pi over 6 before this. And a pi over 6 is a 30, so it means I would stop right here. So in other words, if this were positive, I'm going around once, and then when I go around the second time, I'm stopping 1 pi over 6 short of completing the whole circle. So that much. So let's think about reversing that in the negative direction. I would do 1 full lap around the circle. And then I'm going to go backwards around the circle, almost completing the whole thing, but I'm going to be 30 degrees short of completing it. So that negative 23 pi over 6 is the same as pi over 6. The coordinates there are here, and tangent is y divided by x, so I have to do 1/2 divided by rad 3 over 2. So that's 1/2 times the reciprocal of rad 3 over 2. The 2's will cancel and give me 1 over rad 3. We normally rationalize that denominator, so I would multiply it by another rad 3, which I'm allowed to do as long as I multiply the numerator by that same amount as well. And so I would have rad 3 over 3. So hopefully this helps if you needed a little refresher with the unit circle.